morning, all. Coming to you with another SMO problem. This problem I'm going to show you is similar, very similar to the problem back in 2013. Problem, I guess, was at 13 there. But in any event, this is a short problem. It's supposed to be easy. It wasn't particularly easy for me, I'll have to admit. But what's going on right here is we're given this information that m-3 is a positive integer or a natural number. And that means m would have to be a positive integer or a natural number as well. Now, and we're given that it's a factor, and maybe you could call this divisor. It means the same thing. Factor and divisor are the same in this context. But remember that this is an integer expression. This is an integer expression. And you're given that's some powerful information that m-3 is a factor or a divisor of this integer. Now, let me just give you just a little bit of stuff that helped me on this. Like, say if you have, let's say 10 divided by 2. Okay. Well, we know 2 is a factor of 10, right? Or a divisor of 10. It's equal to 5 with no remainder, right? No remainder. All right. I just put that there for emphasis plus 0. But 2 is not a divisor of 11, right? Because if you write this as write this in this fashion, you see that you have a non-zero remainder. In fact, it's a fractional remainder, which is kind of the crux of this problem. So the upshot of these two statements is that 2 is a divisor of 10, but 2 is not a divisor of 11 because you have this proper fraction remainder. And that's exactly the setup we have over here. Now, I didn't show you the long division, folks, but if you do the long division, if you divide m-3 into 5m squared plus 2m plus 6, you do get this expression right here. This would be the quotient. And one way to see this pretty quickly from algebra, notice that if you substitute 3 into this expression right here, if you substitute 3 right here, you actually get what, 45? I think 5 times 3 squared is 45. Plus 2 times 3, which is 6, right? Plus 6 again. And ladies and gentlemen, that's equal to the 57 that you see right there, right? And so you know that's going to be your remainder. That's a result that you see a lot in your college algebra classes, for example. So what we have here is this remainder, but we want this remainder to be an integer, okay? We want this remainder to be, I call it a member of Z, or a member, let's just call it a natural number, folks. N for natural numbers, those are the numbers 1, 2, 3, 4 ad infinitum, right? So we need to force that to happen for this guy to actually be a factor. In other words, so you'll have m-3 times another integer factor equals to the original expression, okay? Now the m's that are going to do the job out here, notice that 57 has divisors of 1, 3, 19. Okay, and of course itself. Any number, any natural number is a divisor of itself, right? Okay, so we have to force this to be, for right here in this particular case, m would have to be equal to 4, right? Because 4 minus 3 is 1. Now, what would m have to be in this case right here? What do we need? We need m to be what? 6. 6 minus 3 is 3. So it would be 6. Okay. Then what about right here? 23, or excuse me, 22. You know, I'm just trying to do the arithmetic here in my head. 22. See, that would force these divisors to be in the denominator. All right, and then what do we need for this? 60 maybe? Okay. So again, y'all, what I'm doing here is 60 minus 3 is 57. So that would give us 17 plus 1 is 18. This would be a factor in a non-fractional form. Okay, and then the same thing for 22. 22 minus 3 is 19. 57 minus divided by 19 is 3. 6 minus 3 is 3. 57 divided by 3 is 19. And finally 4, you know. So you can see how this happens. These are the possible divisors of 57 in this top row. And these are the values of m that will induce those divisors. Now, just to make sure I'm being clear, let's say we were doing m equals 22. We'll work with m equals 22. That would give you this this factorization right here, and I'll just leave it like this. You would have m minus 3, okay, times, now, so what are we using right here? We're using 22. So that would give us, that would be times 5m plus 20. See, and it becomes a little clearer now what's going on here. At first, I didn't understand this, and I had to really think about it pretty carefully. Right? Again, folks, and that's for the choice of 22 here for m. Now, notice I still left it in the form of m, but notice that if you look what happens if you put 22 in here, you would get what? 19 times 100 and what? 30 maybe. But in any event, that would still be a divisor of this number. Okay, so that's the main idea right here. And you would get factorizations like this for all the others. I'm just showing you one example. But the key aspect of the problem is just to ensure that this guy is a natural number right here, so that you'll have the product of factors that are integers. You know, we need to maintain the integers. So everything inside's going to be an integer, and we can't have a fraction here. It's the key aspect of this problem. So anyway, I hope that helped. Let me know if you need any help with like the long division or anything, or if you just the process. And I hope you enjoyed. Sorry. We're not done. There's the answer to this. Determine the number of all such m. The answer is going to be 4. Okay, the answer is going to be 4. Sorry about that. Answer to the question is 4. And these are the 4 m's that get the job done. Everything else would result in a fraction, which we know we can't have in order to have a divisor going on. So that's how that works, folks. It's kind of interesting. Now, the problem they ask, the direct problem they asked was to add up these numbers. Okay, so for the actual problem, the 2013 problem, they ask you to add up 4 plus 6, okay, plus 22 plus 60. Like that. And ladies and gentlemen, I believe that adds up to 82, 88, 92. So this is another possible answer depending on the nature of the question. Okay, so the sum of the m's that meet this criterion would actually be 92 if I haven't made a mistake on my arithmetic. So this is the answer. This is the question I asked. This is what they ask in the Olympiad. So 82 plus 6 is 88 plus 4 is 92. And that's the answer to that one, folks. Please let me know what you think.